whatever word you are seeing clustering, this is completely unsupervised learning. Okay? So classification, when we talk, it is a supervised style of learning. When we talk about the clustering, it is an unsupervised style of learning. Now, we have seen individual classifiers. SVM classifier is there. Okay? Decision trees are there. Random forest is there. K nearest neighborhood is there. K means clustering is there. So on. The list is never ending. Okay? These many classifiers are there. There is a first title. It is known as ensembling models. Now, this is a new technique in the machine learning or in AI that has been developed for both the concepts, for classification as well as for clustering. So all these classifiers I am combining. Okay? Now let us see one example here. One particular task is assigned by the management to Balaji Sontake. The same task is assigned to Asif. The same task to the Kanaji and Datta Sumunshi. Now let us consider this. These are the 4 classifiers. Now each classifier's performance I am going to management is going to compare. Who is doing the best? Let us start with the otherwise. So Balaji has done some 30 to 40% correct work. Okay? And Asif has done something 50% correct work. And Kanaji has done some 70% correct work. Now, I am not favoring Sumunchi sir that he has done as 80% correct work. So, nobody has achieved 100%. Now, the same task is given. I am combining their work task. 30%, 40%, 50, 80, whatever. I will combine it, I will make it as 100. I will make it as 100. Okay? Accuracy of Balaji Sontake, accuracy of Asif, and accuracy of these 2 guys. So, I will combine it. If I am combining n number of classifiers, that will become my ensembling model. I have ensembled these things. Got it? I am combining. Now, here there is a concept fusing, combining weak learners. The algorithm which is giving very less accuracy, 10%, 30%, 40%, not 100%. If it is a 100%, then it is a strong learner. If it is a weak learner, we are taking the output of that classifier. We are taking the output of another classifier. We are taking the output of another classifier. We are combining and we make a model called as an ensembling model. And this ensembling model is used for both the purpose, classification ensembling models, clustering ensembling models. Okay, so I don't know how far I will complete all these topics because it takes a lot of time. Some mathematical concepts are there. Again, we need to switch to the programming part also. It takes a bit time. I try to finish it or wind it up between these 3 days, and let us see how the things will work it out in our favor. Okay, so here we will step into the machine learning part as an introductory. Before I start this one, we are learning machine learning. Suppose if this workshop has not been organized and management has told you to learn machine learning yourself, what you will be doing? You will be going to YouTube, Google, many other options where and you will be downloading the material, you will be going through that one, you will be studying, and some concept you can grasp it, but some concept you are not able to get it, and some concept you are reading once, twice, thrice, but still you are studying to get that one. All these things will be right. But apart from that one, some of them has learned very correctly by downloading all the materials and all those things stuff. Okay, so here now you are learning machine learning and I am teaching to you. I am not still expert in the machine learning. Still, I am studying. I am a student. So here, I am teaching and you are learning. This type of learning is called as supervised learning. You are learning under the supervision of someone. When you learn itself, that is unsupervised. Okay. Now, if I ask certain questions after some couple of hours, if someone is answering correctly, I say good. If someone is not answering correctly, I may correct that. Isn't it? So this is the system in the supervised style of learning. So here we start with this. Supervised machine learning is the type of machine learning where machines are trained by using labeled training data. See the word, it is called as a labeled training data. Okay? For every input, there is an output. Now, if I say like this, we take a vector. This is my input now. Okay? For this input, whatever output I am giving, if I pass this input, okay, the output should be like this. In the same sense, whatever input is there, that input is having a certain label. We call that as a class information, or we call that as a class label. Here, that is called as a labeled training data. I will come to the word what is training data and testing data. You might have heard it. So many of the seniors, they know that. The labeled data means some input is already tagged with the correct output. Okay? Let us consider that we have developed an algorithm, and that algorithm we are giving a task to recognize our faces. If I pass my photograph, it has to give the output as S.S.Chowhan. If I pass madam's photograph, it has to give Mamune madam as an output. Suppose if it is giving Mamune madam's photo and it is giving name of Hawe madam, that is wrong. Okay, so we need to train it that. So we will teach, and the best example we all have done, those who are married and having kids, those who are bachelor, still that is the concept we will be getting later. Suppose if our child is a kid who is entering into the school, we are training him. First letter we will train him A. Okay, and we will tell him to overwrite on 1 time, 2 time, 3 time, 4 time, 5 time, 10 times. After that, we will erase that one from the slate and we will tell him to write A now. The child will be writing something quite like this. Okay? Means that after writing 10 times, he has overwritten on the letter. Now he learned what is the character A. Now again, we will teach him B, C, till Z. All 26 characters we are teaching him. Now, we have to test him whether he has learned correctly or not. Okay? So now what we will do, we will throw random letters in front of him. Once I will throw Z, once I will throw X, once I will throw B, once I will throw M, L, like this. If he is recognizing very correctly, to some extent he has learned the character correctly. Suppose if I am giving him input like this, are you getting me what I am trying to say? Is there any similarity between the pattern? Sir, yes. He may get confused. Again, for this also, have you observed certain errors in the script? Yes. Immediately, हा लाईन असा आहे, इथून सर्कल झाल्यानंतर ते बी आहे की डी आहे, मग तो थोडा विचार करणार. एम आणि डब्ल्यू, डब्ल्यूला रिव्हर्स करा, काय होतं? एम, एमला रिव्हर्स करा, So this patterns like this. Now, even though in spite of this, he has learned to identify the correct pattern, then the training was successful. What he is doing is generating or giving the correct output as a M and W. So here, that is what label data means some input data is already tagged with the correct output. Okay, again in the supervised learning, the training data provides to the machine work as a supervisor that teaches the machine to predict the output correctly. Okay, we have trained the child. If I pass this input, he is giving this is M and he is giving this is W. That is the correct output. Okay. Next, it applies the same concept as a student learns in the supervision of the teacher. Okay. Today I will teach you that y is equal to mx plus c. The line is passing through the origin. Now, this equation you need to apply for regression. There is a difference between regression and classification. There is a law. Okay? So, here, this is a dependent variable and this is an independent variable. Dependent variable as well as independent. Whatever x value is we are giving an m value and c value, we will get the y value. Y is depend upon x. So under the supervision of the teacher, the supervised learning is a process of providing input data as well as the correct data to a machine model. Okay, so I will talk this after completing this. Okay. The aim of supervised learning algorithm to find a mapping between input and output. What the input is and what will be the output. Okay. So with the output variable y, the real world supervised can be used on risk assessment. Okay, in insurance companies, image classification. There is a bunch of images or a group of photo, and now you need to identify who is that. Next, fraud detection. बरेच जण आपण क्रेडिट कार्ड घेण्यासाठी आणि घेतल्यानंतर हे करत नाही. त्याच्यानंतर स्पॅम फिल्टरिंग. ओके, हा जो मेल आलेला आहे तो स्पॅम आहे का हॅम आहे असं आपल्याला ओळखायचं. सो दिस इज वॉट. ओके, अँड मेनी अदर ॲप्लिकेशन्स. सो नाउ लर्निंग मॉडेल आय सेड. हॅव यू हर्ड द वर्ड डेटा सायन्स? We use the term AI, machine learning, data science. All these, they are interconnected to each other. Okay? There is a life cycle of data science. In data science, what happens? We collect the data. Once we collect the data, we will get a raw data. The raw data, which is not a proper data, it is not a structured, it may be unstructured, it may be semi-structured. Semi-structured means some part is structured and some part is not structured. Okay, again, you can see that in this world, in this global, we all are using the gadgets. For every minute, every second, an image, a file is being uploaded on the internet. Till now, from last 1 decade, every day, 2.5 quintal tons of data is uploaded on the internet. So that is why it is called as a big data. Huge data, enormous, massive data. Okay? So that data we will download, that data may be in a proper format, and then we will try to use it. While using, we need to do. The first step, collect the data. Second step, clean the data. Then third step, data wrangling comes in the data science. Once the data is in a structured form, now generate, now this is what till here data science. Okay, now generate a model to apply on this data. Okay, now machine learning starts. Again, once the model is generated, try to visualize the data. Try to analyze the data. Again, data science started. Try to visualize the data, try to analyze the data, try to make the analytics of that, okay? Then predict the data. Now I have done for some particular marketing company one model. So I cannot use the same algorithm for the different, for advertisement company. What Netflix is doing, recommendation algorithms. Okay, if you search certain thing in the Google of a certain cosmetic product, let us see. So there are thousands of list that Google has given, but which is the best quality? How will you determine? What is the procedure? This is Himalayan products are the best quality, we will say like this, just for an example. We are not marketing them.
First, we have to define the standards.
What kind? Previous data. Any other? Sales. Okay.
Likes and comments.
Huh?
Likes and comments.
Can you come again?
Comments.
Out of that, we need to check the top listed ranks. First rank, second rank, third rank, fourth and so on. So from this we need to check which is the best. Now Netflix, what it is doing? Hey, how many customers are there who are watching only a comedy movies? Who are watching thrillers? Who are watching only horrors? Like this, the categorical based data is creating. Based on that one, okay, a recommendation algorithm is given. Okay, आपण बरेच वेळेला Amazon, Flipkart वरून ऑनलाइन भरपूर प्रोडक्ट मागवत होतो. We buy those products. Second time, suppose I have purchased a mobile from Amazon. Second time when I go to the Amazon, it will show some suggestions, advertisement for us that this is recommended for you as a pen drive or a laptop, any other related things. Okay, like this. This is a recommendation algorithm. And second one, we visit to Vishwa superstores, all these malls. Okay, directly we take a basket and we start shopping ourselves. If I purchase a milk, I will purchase a tea powder also. I will purchase a bread also. I will purchase a biscuit also, because that is related to tea, milk. This is nothing but association rules. Okay, see the interest of the customer. If he is purchasing a milk packet, along with the milk, what is the requirement for him again? This is to increase the sales. Okay, so this is what will step into the next slide. Here, the working of supervised learning can be easily understood with this diagram. Labeled data. Can you see some shapes are there? By looking at those shapes, we will identify it is a square, it is a rectangle, it is a hexagon, and it is so on whatever. Okay? So, I think there are three categories: hexagon, square, and triangle. Apart from that, there is no other shape. Now, how many categories are there? Three categories. Assume that there is a machine learning model. Now, this model, we are passing this data to this model. Okay, this model has to predict if this is the input and this is the input. It has to say it is a square and this is a triangle. The same example what I have used for the small kid. Okay. Now, whether this model is predicting correctly or not, I am using new data, unseen data, which was not used in the training. Okay, which was not used in the training. Now I am giving that into the input to that model that now it has to predict. So if it is predicting the language, suppose if we have a data set of different types of shapes which includes these many patterns. train the model for each and every shape. After that, we need to test. This is what, there are two concepts we call as a training data, and the second one is as a testing data. Testing data is not used, it is used for validation purpose. Training is used for training data. We have to split our data into two sets. One we will call that as a training, and second is the testing. So mainly the ratio, some researchers may call 70-30 and some researchers may call 80-20. Ratio of the splitting the data. 80% डेटा आपण ट्रेनिंग साठी वापरतो, 20% डेटा आपण टेस्टिंग साठी वापरतो. This is what. So here with that, if the given shape has 4 sides and all the sides are equal, then it will be a square. I will repeat the statement. We will expect once we will remember feature extraction. We took your help there. So, I repeat the statement. If the given shape has 4 sides, side is the feature of square. How many should be there? If it is 3, triangle, not rectangle. Now again there is a confusion. Rectangle is also having a 4. Square is also having a 4. Now, there's a M and W circle other situation. Okay? So, here, see here, if the given shape has 3 sides, it will be labeled as triangle. If the given shape has 6 sides, it will be labeled as, based on this and this, the model is telling which is the shape. Are you getting my point? Based on those sides, the model is predicting which is the shape. This is the features. So now, after training, we test our model using the test set, which is not used in the training. Unseen data for the model. Seen data was the training one. As I took the example of our family member who is standing in the crowd with a distance of some 10 meters, we took immediately to recognize that what pattern. That person is our family member, she is my mother or father. This is what. So sometimes if our friend is also standing from 100 to 200 meters and there is only partial view, as a scientist visitor, there is a partial view, still we will recognize the data. Because that pattern is fixed into our mind. Okay? Another one thing, we have learned tables in our school days. From first standard to second standard. So, right from 1 table to the 25th table, let us take like this. Suddenly you are making certain calculations. When you visit to any grocery shop and so, you want to make a total. So, you have purchased 4 items and the item is rupees 8 cost. And some of the items, 2 items, 3 items, so many mingling of data will be there. Suddenly when you come across 4 items, say पाण्याची bottle घेतली and 8 4 8 32. असं करत आपण calculation करतो. Do you remember this one, such type of things? We do perform in our life. Suddenly if we miss something, we will start our table from first again to that point. Isn't it? We do it. And we go back and come again. So if the model in the first training is not giving correct output, train it, retrain it till it gives the correct output. Then go for again testing. So the machine, it is a categorizable mistake. The machine is already trained on all types of shapes. When it finds a new shape that is not in the training as well as in the testing. तिथं आपण 3 शेप्स पाहिले आहेत, ट्रायंगल, स्क्वायर, अजून हेक्सागोन. आता ह्याच्याऐवजी मी जर तिथे सर्कल पास केलं तर सर्कल काय झालं, अनसीन डेटा, न्यू डेटा इट इज कमिंग. इट हॅज टू प्रेडिक्ट दॅट ऑल्सो. ओके, आपण ट्रेनिंग कसं दिलेलं finds a new shape, it classifies the shape on the basis of the number of sides and predicts what is that one. That's why it got 6, 3 and 4. Okay. So if circle is given, now how many sides? No sides. Found that? Okay. Now supervised learning is categorized into two. One, we will call that as a classification, and second, we will call that as a regression. In regression, again, there are n number of types. Linear regression is there, polynomial regression is there, multiple regression is there, so on. Okay? So these regression algorithms, I have taken one example here about the regression. Before we take the cursor on Python regression analysis, first we need the regression. Maybe only writing notes if it is necessary. All the slides I am going to give you. Okay. Okay. The board आवाज़ में लेती है पेपर में. Okay. So linear regression. Let us consider that before coming to regression, we will go to the classification part. Now, in supervised learning, we are having two concepts. We call that as a regression, second we call that as a classification. Now, assume that there is a box. I repeat, there is a box. In that box, I have kept 4 colors of chalk piece mixed. Red, green, blue and white. Red, green, blue and white in that box. I will give a task. I say that what you have to separate all the colors. Just simply seeing at the color, you keep red color one side, green color one side, blue color one side, white color one side. First time when you are picking up, do you know which color is coming in your hand? What is the probability of coming red color in your hand? Probability. Do you know the word? This is a statistics. Which is? अपन एक word, हम लोग एक word use करते हैं, अंदाज लगाना. Yes, predict. Yes. So initially we don't know. So which color is coming in our hand? The probability of the red color is 0, probability of green is 0, like initially the first one. So let us say I have picked it up, I have got the red color chalk piece in my hand, I will keep in one side. Again I have got a green, I will keep on one side. Second time again green, I keep in the green category only. Third time I picked up blue and fourth time white. So I told in a box bunch of chalk. Let us say that n is equal to 50 chalk piece will take. How many? 50. As we repeat the process, all 50. We have done it to 57. Sorry, 47. Okay? Assume one scenario. How many chalk pieces left? 3. Assume that the first scenario, red, there is one red. Second, there is one green. Third, one is blue. Now, what is the probability of coming red, blue and green? I say, as per my opinion, 50-50-50. Probability of? Do you know what is the probability? are left. One is red, one is blue. What is the probability occurrence of blue and red? 50-50. Now consider that only blue has left. What is the chances of blue is coming now? 100%. This is called probability. How did you say only one it is, then all of the sudden everyone uttered 100%? It was so simple, 2 seconds. So in this way, so probability need to be calculated at every step. Okay, now classification. Now coming to the part, we have taken 2 features. One, okay, there is a person X. When I say there is a person X, what are the features can you predict or can you assume? Can you assume? He is a human being. Sometimes he is a X. आता माझे features काय तुम्ही define करा. Height, okay, weight, color, face, okay, shape of the nose, shape of the ear, distance. Yeah, this is the distance. Distance between eyes, ear. I take it here. Color of eyes. Very good. Voice. Okay. All these are the features. Is it? Suppose if I say, will take color of eyes. My eyes color is black. Is it same with Somanshi sir? He may be having brown. Okay. So if I say Herbert sir, he may be having cat eyes. Sorry, not like that. Just to make a certain discrimination between the input, I am taking like this. Okay. He may be having this type. So every person is having a unique feature. Okay. Another feature nobody has told is, are you were feeling shy to say that one what he will feel? How we are, we have to adopt ourselves. First try to love yourself, then you can love to others. Okay, coming back to that, here I have considered only 2 features. What is that? I don't need to say. What is that? 2 features. I have written on x-axis H, on y-axis W. H is indicating height and W is indicating weight. Is it clear with that? Okay. Now, we are having some 50 faculty members. We need to identify who are they. Okay. We will start with the weight. 10, 20, 30, 40, 50. I need to increase because by looking at the producer. 60, 70. Is it enough, sir? Increase? That is the weight.
You can increase that up to 100.
100. Who? You? Okay.
100 only, sir.
Okay. Now, starting from the 10 to 120, we all will fall in this category. Isn't it? Everyone is having weight. Now, let us consider the height. We will start with 3, 5, 7, 9. Not more than that. Okay? I will start from my side, okay? From my side. Okay? I will consider me only. So here my weight is 65 to 67 kilograms and my height is 75 point. Why I have to like that? See, my weight is 65, just assume, and my height is 75.5 to 39. If I compare this and this, it is intersecting here. Now I am falling here. This is Mr. S.S.Chowhan. 5.5 height person, you have represented in a two-dimensional space with a single dot. By using how many features? Two features. In the same way, all the patterns who are sitting here, I can represent them on the two-dimensional space with the dot, having with the two features. Okay, so let us consider here somewhere 100 our professor is falling, somewhere 50 some other staff is falling, somewhere here another staff is falling, somewhere here another staff is falling. Can you notice where on the two-dimensional space for every staff member I have given a different symbol. So which is an asterisk, for me dot, and someone else triangle and someone else circle. Why this is necessary? सगळ्यांना डॉटच दिलं का? What we are doing, we are discriminating this data. Asterisk type belongs to principal sir. Okay, dot belongs to me. Suppose triangle belongs to him. If I extend, how many features we have taken? If I extend another feature here, now how many dimensions? So before coming to the 3 dimension, we will stick on to the 2 dimension. Later on we will. Okay, I kept myself a professor. So we will consider how many persons are there? 2. So I will say class 0 and class 1. Class in the sense category. Okay? 2 categories are. So let us consider that some of the patterns are in this case. So only 4 patterns. Okay? Write a program to generate, don't write it, I understand. So write a program to generate a line between 2 classes. So this is what I will say. I will draw a line like this. Let us consider this is C0 and this is C1. Have I separated these 2 classes? They are separated? Yes, they have been separated. One class is on the side of the line and another is another side of the line. Okay? Within the 2-dimensional space, we have separated these 2 classes. Class 0 as well as class 1. Now this type of thing, I will call it as a classification. Now this line I will call as a decision line. The decision line between the 2 classes. What is the role of the decision line? It is separating 2 classes. Okay? Now let us take one example here. We will take a XOR function. Omega madam is there to help us. She belongs to electronics. Am I writing correctly the function? That just to check it out. With the 2 inputs, x1 and x2 and the output. If I pass 0, 0, XOR function I am talking. 0, 1, 0, 1, 0, 1, 1, 1, 0. Am I correct, ma'am? Okay. I have taken how many inputs? 2 inputs only, x1 and x2. So let us plot this one on the 2 dimension. Okay. x1, x2, 1, 0, 0, 1, 0, 0, 0, 0. What will be the output? 1, 0, 1, 0. What is the output? 1. Is it correct plot? Still not understanding? I will change the pattern. Initially we are passing 0, 0. Output is 0. Let us keep it here. So 1 and 0. 1 and 0. What is the output? 1. Next 0 and 1. What is the output? 1 and 1. I am passing. What is the output? Now it is correct? Got it? Now generate a single line to separate the 0 and 1. Is it possible? Single line not possible. So if I pass like this, I can't. This way, this way, this way, this way. Not possible. Now, this is XOR problem. Okay. Now I will take your. Is it visible this one or this cooling is coming? So here I will take OR now. X1, X2 and output. So 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 1. Okay, the plot may be quite like this. 1, 1, 1 and 2. Is it correct? Now, for that, draw a single line to classify. Easily we can draw it like this. So if I draw, 1 is falling on the one side and 0 is falling on the other side. What happened? We have classified the data. Okay? So this complete set is one category and this is another category. X1 and X2 whose inputs are 0, 0, they are giving the output as 0, and whose inputs are this one, they are giving the output 1, 1, 1. Now this type of problem, I will call this as a linear classification. And this, we need 2 separate lines, which is not possible with the one single line. I will call this as a non-linear classification. Got it? In classification, we are having 2 types. What are those? Linear and we have seen the example of non-linear is an XOR problem and linear is OR problem, and is also linear. The output will be reverse. So instead of 0 there will be a 1, and instead of 1 there will be 0. So XOR is an example of non-linear classification, and OR and AND are the example of, I am telling example of linear classification. Now when we learn a machine learning, okay, so maximum real world real-world data is on non-linear classification. Okay? Maximum data is on non-linear classification. So the model is to be generated. The model is to be generated so that that particular model should classify non-linear data correctly. Are you getting my point? Classification, two categories. One is linear, another is non-linear. Linear examples and non-linear examples we have seen. So here, regression, I'll go back. The second category in supervised learning is regression. So in regression, algorithms are used if there is a relationship between the input variable and the output variable. Now just now, I have given an example of y is equal to mx plus c. Okay, so you can see this one. Dependent variable and independent variable. So here, this is what? Relationship between the input variable and the output variable. Output variable is the y and input variable is the x. It is used for what purpose? Prediction for continuous variables. Okay? Such as weather forecasting, market trends. Every time we can't, there may be changes in the climatic situation. So market trends, okay, again, so on, and some of the popular regression algorithms are quite like this. Linear regression, regression trees, non-linear regression, Bayesian linear regression, and polynomial regressions. Now, what are the advantages of supervised learning? In supervised learning, how many categories? Classification and regression. Still, I have not taken the example of regression. I have taken only the example of classification. So, with the help of supervised learning, the model can predict the output of the basis of prior experiences. Okay? In supervised learning, we can exact the idea about the class and the objects. Supervised learning model help us to solve various real-world problems such as applications, fraud and spam and so on. Disadvantages of supervised learning. Supervised learning models are not suitable for handling the complex tasks. One of them is. Okay. So, a simple, it is a non-linear separable data. It can be learned, it is not like that, it can be learned and separable. Supervised learning cannot predict the correct output if the test data is different from the training data. Training requires a lot of computational time. That is expensive in terms of time. In supervised learning, we need enough knowledge about the classes of objects. Means we need more data and the classes should be labeled every time. So, I will take an example that later on labeling data. Now we will switch on to unsupervised learning. Unsupervised learning is a type of machine learning in which models are trained using unlabeled data. This is the difference between supervised and unsupervised. In supervised, we have labeled data. In unsupervised, we have unlabeled data. Okay? So, what is the how? We have seen the example of classification here. regression. Now here so unlabeled data set and are allowed to act on the data without any supervision. So the training should be accomplished by self. It has to recognize the pattern. Now let us consider in this example, there are two groups. One is having this pattern. All patterns are same. This is a homogeneous group. And this is another group. So instead of using a word, I will use here C1 and I will use C2. Class 1 and class 2. Later on I am going to change the word. So instead of group, what I am saying here, class 1 and class 2. So I am going to collect the same patterns, homogeneous patterns of the each group. Okay, so here let us consider there is a new pattern, it is falling here. Now I should check or determine this pattern belongs to either this group or this group. Either it should be C1 or C2. If it is not C1 and C2, then also it is some solution is there. We will come to that point later. Okay, so in unsupervised learning cannot be directly applied to the regression or classification problem because unlike supervised learning have input data, no corresponding output data. So we cannot apply this supervised learning style because we don't have labeled data. Now this is the part of what is this? Can I say C1 and C2 are the two clusters? Now instead of class, we will use the word cluster. C1 and C2. Now I have to check this input pattern belongs to cluster 2 or cluster 1. How? There are different methods. We call that as a what is that? Is that distance measures. There are a number of algorithms, methods. Now let us say this part. Now we are having the inputs. How many categories are there? 2 categories. Okay? So the model is here, it is processing and it is generating the output. This category belongs to the cats and this category belongs to the dogs. 2 different clusters. In the same way here. Okay? Now assume that here we are having dogs and cats. Suppose if I am sending a rabbit here. Now yes. We are having a group of cats, we are having a group of dogs. Now we should have a group of, this new group is forming. So if this pattern does not belong to C1 and C2, there will be another cluster called as okay. So here we have taken unlabeled input data, which means it is not categorized and corresponding to the output are also not given. Now this unlabeled data is fed into the machine learning model in order to train it first, then it will interact the raw data to find the hidden part. Okay? classification. In supervised learning, there are two types. One is regression, another is classification. Now, in unsupervised learning, we are having two categories. One is called as a clustering, another is called as a. So this is cluster. Just now I took an example. If a customer is going to a shop or grocery shop or a mall or a market, if he is buying a milk packet, then he may buy tea powder, bread, biscuit, and so on. So that comes from the association. Okay. What is that? Clustering is a method of grouping the objects into clusters such that the objects with the most similarity remains into the group and no similarities within the objects of any other group. Cluster analysis finds the commonalities in same patterns, okay, and between the data objects and categorize them as per the presence and absence in between the data. So if it is that pattern belongs to cat, we will put it into the cat category. If the pattern belongs to the rabbit, we will put it into the rabbit category. Like that. Association. It is a rule in an unsupervised learning method which is used for finding relationship between the variables in the large database. It determines the set of items occurs together. Okay, the same example what I had given, I have kept it here, such as people who buy an X item, suppose a bread, are also, okay, they can buy any other item which is related to that. Any other item which is related to bread. Here we are having certain algorithms, list of some popular unsupervised learning algorithms. First one, K means clustering, KNN, nearest neighborhood, hierarchical clustering, anomaly detection, neural networks, principal component analysis, independent a priori algorithm, and singular value decomposition. All these are the certain methods that are used here. Now, here we know that we are quite aware with the word. What is this? Clustering. K means, K stands for number of clusters. If I say K is equal to 2 clusters. If I say K is equal to 5 clusters. How many clusters you want to form? Okay, depend upon that. So here we come to the point, regression analysis. How many of you apply this one? Regression analysis. Python, C, C++. So regression analysis is a statistical method to model the relationship between a dependent target and independent predictor. Okay? Variable with one or more independent variables. So more specifically, regression analysis helps to understand how the value of dependent variable is changing corresponding to an independent variable. So when the other independent variables are held fixed, it predicts continuous real values such as temperature, age, salary, and price. What do you mean by this? Today morning, 8 o'clock you came. Let us assume like this. What was the temperature? Something 25 degree. Now it is 11:30 or near to 12. Is the temperature remain same? It changes. The second thing, that this year the salary is 10,000. Next year will be same. Might be change. If BJS is filled out, performance based appraisal report. Okay. So again, it affects to the age also. Today I am 46. I may not be in the next year 46. I may go to 47. Okay? So this is what? It changes continuously. Okay, this is an example. Suppose there is a marketing company, the name of the company is A, who does various advertisement every year and get the sales on that. So the below list shows the advertisement made by the company in the last 5 years and the corresponding sales. If they have done $90 advertisement, they have what? How much sales? $1,000 sales. 120, 1300. 150, 1800. 100, 1200. 130, 1380. 200, we have to predict. We have to predict it. Thus, according to the advertisement, the sale is also changing. If I take initially with the $90, the sale is $1,000. If I do with the $150, I am getting 1,800. Isn't it? It changes. Now, the thing is that till 150 we have done it. This year, if I do with the $200, what will be the sale? This is called prediction. Isn't it? So, we may go, I say, if I do with the 200, I say $2,000. This, I am predicting. This is not confirmed. This is what? An example. So, we will continue with that. Now, the company wants to do the advertisement of rupees $200 in 2023. Consider. So, that was the long back I had done. So, and wants to know the prediction about the sale of this year. So, to solve such type of prediction problems in machine learning, we need regression analysis on sales. Okay? I want to predict if I do $200 advertisement, if I spend $200 on advertisement, what will be my sale? Okay? So the regression in supervised learning technique, which helps in finding the correlation between the variables that enables us to predict continuous output variable based on one or more predictor. Okay? So it is mainly used for prediction, forecasting, time series modeling, and determining the causal effect relation between the variables. So these are the areas where regression analysis can be done. So I come to one point. Let us talk on gold prices. In 2015, the gold price was something 35 to 40. In 2023, it went to 64 to 65. Okay. It is rising, it is hike is there. What will be in 2025? Does it come down? Does it go up? How confidently you are saying it will go up only? It may come down. There is a fluctuation in the market. So what we are trying to do with the past 5 years, we are trying to predict the price of the gold. In 2025, what will be the gold prices? Now this is your one of the research problem. You have to spend 2-3 years on this. You have to collect the data, last 5 years data, go for regression analysis, go for making many predictions. Okay, what X person has predicted in 2018, whether his prediction was true or not. This type of thing, analysis you have to do again. This is the basic thing of regression I am taking, ABCD. So in regression, we plot a graph between the variable. Okay, this line is very important, interesting one. we plot a graph. Okay, we plot a graph between the variable which best fits the given data point. Using this plot, machine learning model can make a prediction about the. Focus on the word best fit. Okay, now can you see the difference between two plots on the board? This is class 1 and this is class 2. This line is classified into classes. We will call this as a classification. And this line as a decision line. In general, I will call that as a decision boundary for the two classes. So whatever dots I have drawn, these are the data points which are on the line. Okay? We will come to this point later on. Just I want to show the two different plots. So the word is best fits. Best fits the given data point. Using this plot, ML model can make a prediction about the data. In simple words, regression shows a line or curve. Come to the point. When I say regression, when I use line, it is a linear regression. When it is a curve, polynomial. Okay? So that passes through all the data points on target predictor graph in such a way that the vertical distance between the data point and the regression line is minimum. Okay? So let us take like this. The dots which are outside the line, that is my actual data points. Actual data points. The predicted data points are on the line. Okay, so I want to check the difference between this and this, and this and this. This one. This is the actual one. This is predicted one. This. Okay, I am here. Okay, we will see an example of this. Plus, I want to make a difference between the two plots. So here, which is the best fit? Which fits on the data points? This is my data point, this is my actual data points. Now, distance between this and this. What is that? My actual data point is there and predicted data point is on the line. There is a distance. I need to minimize this one. Okay. So here, types of linear regression. First one is linear regression. Third is polynomial regression. Support vector regression, decision tree regression, random forest regression, rigid regression, lasso regression, and logistic regression. These many types. Just have a look on this, whatever I spoke in the last 2 slides, it's the same thing. Shall I move to the next? What is the example? Sorry. So, before starting this one, we will be what? Refreshing ourselves. Right click, refresh. Okay. We will have a tea break. So, please,